Hi everyone, this is your math guru. Today we're going to learn how to find the subject of the formula as shown in the examples below. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example we have f equals 1 over 2 pi square root of LC, and we are to make C the subject of the formula. Remember that any whole number or any whole variable written as a fraction would be over 1. Because we have fraction on both sides, we are going to cross multiply. And if we cross multiply, we have f times 2 pi, the denominator of the other side, square root of LC, equals, we have 1 times 1, which is 1. If we divide or expand the bracket first, we have f 2 pi, f times 2 pi times square root of LC equals to 1. Because we are trying to make C subject of formula, we have to take every variable or number to the other side. Let's start with R, 2 pi and f. We are going to divide both sides by f 2 pi or 2 pi f. Remember, whatever you do on the left hand side, you do on the right hand side. This cancels as this goes here 1. We are left with square root of LC equals, I'm going to put my whole number in front. So I have 2 pi f to make it tidy. Then I need to get rid of my square root. How do I get rid of my square roots? By finding the square of both sides. So because I'm squaring the left hand side to get rid of my square roots, I'm also going to square my right hand side. The square here cancels my square root. I'm left with LC equals 1 over, I can expand. The square outside means every variable or number in the bracket will be squared. So I have 1 squared over 2 squared, pi squared, and f squared. Laws of exponent. Then I have, let me tidy that up. I have LC equals 1 over 4, 2 squared is 4, pi squared, f squared. And because I'm looking for C, I'm going to divide both sides by L. So let me write it this way so you see what I'm going to do on the other side. LC divided by L equals 1 over 4 pi squared, f squared, divided by L. I'm going to rewrite it on the side. I'm writing divided by L as against writing over L to make it easy for me to swap because I have a fraction on the other side. If I divide this by L, my L cancels. I'm left with C equals, and remember if I'm dividing a fraction, I need to apply 2 rules. One, I change my sign and then I flip my right hand side. So I change my division sign to multiplication and then I flip, this is over 1. If I flip it, it's going to be 1 over L. Therefore, my C, which is my subject of the formula, equals 1 over 4 pi squared f squared L. Let's go to the other example. In the second example, I have T equals 2VR all over P plus 2. I'm to make P the subject of the formula. Like I said earlier, any variable, all variable or whole number is over 1. I'm going to cross multiply again here. And then I have T times in bracket. I'm going to put that in the bracket because it's an expression. P plus 2 equals 2VR. I'm looking for P, so everything attached to P, I'm going to take to the other side. Let me start with my T because it's multiplication on this side. I'm going to be dividing both sides by T. This cancels. I'm left with my P plus 2 equals 2VR over T. Then I need to take 2 to the other side because it's plus 2 here. That means I'm going to apply in the balance method. I'm going to subtract 2 from both sides. Minus 2. 2 minus 2, this cancels. Therefore, my P equals 2VR over T minus 2. Note that I can decide to tidy up things a bit to make it them have the same denominator or put them under the same denominator. This is a whole number, so this is over 1, so I can further simplify because my LC, lowest common denominator here, is t. I'm going to multiply the right hand side by t to make them have the same denominator. So I still have my p equals 2vr over t minus, I have t over 1 times t at the top times t at the bottom. It's the same as multiplying by 1 because t divided by t is 1. From here, I'm going to have 2vr over t minus 2t over t. And remember, if you're adding or subtracting fractions, if or once the denominator are the same, then you can put the numerator together, putting them under the same denominator. I'm going to have p equals 2vr minus 2t all over t. So I have this or this as my correct answers, making p the subject of the formula. In my third example, I have h equals the square root of, I have a squared over 4 plus h squared. This is over 1, like I did in the previous example. Because I'm making a the subject of the formula, I need to first of all get rid of my square root. And how do I get rid of my square root? I'm going to square both sides. The square root is going to cancel my square. So I'm left with h squared equals a squared over 4 plus h. I'm looking for a, so I can first of all get rid of my h squared. Because it's plus h, that means I'm going to subtract h squared from both sides. I have h squared minus small h squared equals a squared over 4 plus h squared minus h squared. This cancels. I'm left with h squared minus h squared equals a squared over 4. All this I can place over 1. I can also swap my equation around. I'm going to continue on this side to have a squared over 4 equals h squared minus small h squared over 1. To get rid of my 4, I'm going to multiply both sides by 4. So I have a squared over 4 times 4. Whatever you do on your left hand side, you do on your right hand side. All this times 4. I don't need my divided by 1 at the bottom. This cancels. I'm left with a squared equals 4 in bracket. I'm bringing my number to the front. H squared minus h squared. Now to get rid of my square, I'm going to find the square root of both sides. Therefore, the square root cancels my square here. I'm left with a equals square root of 4 in bracket h squared minus h squared. If I take my 2 outside, I can leave it this way. I can take my 4 outside. Square root of 4 is 2. I have a equals 2 square root of h squared minus h squared. Let's try out one more example. In my last example, I have r equals r in bracket I plus theta t. I'm to make t the subject of formula. Making t the subject of formula, I need to first of all get rid of my r, and I will do that by dividing both sides by r. That's the small r. This cancels. I'm left with capital R over r equals I plus theta t. I can swap my equation around. I have I plus theta t equals r over r. I'm looking for t, so I still need to get rid of my I because it's plus. That means I'm going to minus I from both sides. Always remember, whatever you do on your left hand side, you do on your right hand side. So I have r over r minus I. I minus I, this cancels. I'm left with theta t equals r over r minus I. Then I divide both sides by theta because I'm to make t my subject of formula. But instead of writing my divided by t, I'll rather write it as, or divided by theta, sorry, I'll rather write it as divided by theta. So I'm going to correct that quickly. Okay, I wrote it that way to make it easy for me to change my division sign. That is, I usually do that if I have a fraction on the other side. This cancels. I'm left with t equals r over r minus I, all divided by theta. I'm going to tidy up my right hand side quickly. I have t equals, in the bracket, I can make r over r minus I have the same denominator. My LCD there will be r. So if I have r over r minus I over 1, then I'm going to multiply the denominator and the numerator by the small r. Remember, I still have my divided by theta outside. This is going to give me t equals r over r minus ir over r. I still have my divided by theta outside. Now the denominators are the same. I can put them together. I have in brackets capital R minus IR, applying the rules of fraction if you're adding or subtracting, divided by theta. Now I can change my division sign to multiplication, and then I swap my right hand side. Over R, this is going to be times 1 over theta. So therefore, my t is going to be r minus ir, that's times 1. So I have the same thing over r theta. Thanks for watching. Bye.